Okay, so we are doing functions and we are doing transformation of functions first. All right. Transformation. So in HLAA, we have one that is translation. Fetch and reflection. Then we have few more transformations, that we'll discuss later. So first we are doing these three type of transformations. So let's do the translation first. In translation, when we have a function fx and we are translating with a vector hk. So h is here horizontal translation and k is what? Vertical translation, right? Horizontal translation, so I've written in short ht and vertical translation vt. So let's say fx, when we are translating, then we can write fx minus h plus k, right? That's how we can write when we are translating. So what the fact happened to the graph?
So it goes up by k and it moves right by h.
Absolutely. Let's say I have a quadratic curve. So it moves h point to the right or left, depend,
Yeah,
and k point up or down, depends if it is positive or negative. So let's say if I'm translating 5 points to the right, so h is 5 and 2 points up, so k is 2. So translation is 5, 2. So what I can say, let's say fx is equal to x square, then our new function gx will be equal to h will be equal to f x minus 5 plus 2, right? So we can simply write it as x minus 5 whole square plus 2, isn't it? So the vertex, which is 0, 0 earlier, has become new vertex 5, 2. And every point is translated, in the same order. This point is clear to you?
Yes.
Let's see one more. Let's say if we are translating 3 points to the left and let's say 4 points down, So this will get 3 points, 1, 2, 3 points left, and 1, 2, 3, 4, 5, 5 points down. 1, 2, 3, 4 points. 1, 2, 3, 4. And let's go. And this is so new vertex will be somewhere here, and our curve will be something like this. Something like this. We don't know at what point it's intersecting. That we can check it after we get it. So fx will be equal to x, not fx. I write some different function hx, let's say. So hx will be fx plus 3, because this always happen opposite. Minus 4, right? Before it was positive, and we see it was turning to negative. This time it is negative, it is turning to positive. While the vertical translation remains same, it was 2 earlier, it is 2 only, positive, and this time it is negative 4, so it is negative, right? So what is the function then? X plus 3 whole square minus 4. And if you are looking at the roots, then roots will be x plus 3 whole square is equal to minus 4 is equal to 0. So x plus 3 whole square is equal to 4. X plus 3 is equal to plus minus 2. And x is equal to plus minus 2 minus 3. That gives us minus 1 and minus 5. So -1, so this point is going to be -1 and this point is going to be -5. And vertex is going to be what? By what we have translated. -3, -4.
Yes, sir.
Right?
-3, -4.
Correct. The original vertex is 0, 0. Okay. So that's how we have a different function, which is hx.
Got it.
Earlier we have fx. This is x-axis, this is y-axis. Okay, so this was translation, and this can happen like to any function actually. It's not about quadratic. Like say if I have, for example, e to power x, and I'm translating, let's say -4 and 5, this is. So what is my function then? Hx, you tell me.
Okay, so if you e to the power x -4, 5. So first it will be, so hx will be, translation will be, right? So is x plus 3. So it will be, so x minus, sorry, it will be x plus 4. Sorry, x minus 4.
Yes, x plus 4.
Oh, x plus 4, sorry, x plus 4. And then the whole term plus 5.
Plus 5, right.
Yeah.
So that's our new translated, right?
Yeah.
And it can be seen like e to power x can be drawn something like this. So it is moved 4 point to the right, to the left, right? To the left.
Yeah.
1, 2, 3. So it's -4 and 5 point up. So 5 point up. 1, 2, 3, 4, 5. 5 point up. So basically, the point, like it is how it is going to be. We have a horizontal asymptote, Before a horizontal asymptote was y is equal to 0. Now we have horizontal asymptote, which is 5, This is the line, right? This is the line, and our curve is something like this, isn't it? Our new curve is something like this. Right?
Yeah.
If I'm putting here x0, then what I'm getting? e to power 4 plus 5, That is what? Y-intercept. Y-intercept. e to power 4 plus 5. So that's the y-intercept. All right. So that was a translation. Now, second, we are doing stretch. So stretch is something when points either go away from x-axis or come close to the x-axis.
Yes, sir. So
right? That is called vertical stretch, right?
Yeah. So like if it's 2 fx, so it will be vertically stretched by twice,
Correct,
times,
correct.
right? And if
Correct.
it's f 1 by 3x, then it will be horizontally stretched by 3 times.
Right. So I can say like afx, right? So over here we have vertical stretch by scale factor is equal to a, isn't it?
Yeah.
Right. That's the vertical stretch. So over here, if a is greater than 1 or a is less than 1 but greater than 0.
So just a moment. Hello.
Yeah.
Just a moment. So wait. Now it's fine, sir.
Okay. So basically a is greater than 1. What happens then? If a is greater than 1, the scale factor is greater than 1. Then points go away from x-axis, isn't it? All the points. And if it is less than 1 but greater than 0, then points come close to the x-axis. But all the points at x-axis remain invariant. Points at x-axis will not change.
I understood.
Right. So, so it can be drawn something like this either, maybe when a is less than 1, or it can be drawn like this, something. When a is greater than 1, right? So this is when, let's say this is fx, this is something 2fx, and this is something 1 upon 2fx, right? Okay. Let's see one more example here for this. Let's say if I have a curve like this, something like this, something like this. Or I'll make a different curve, maybe like side, like periodic curve. That would be better. Let's see like this, So now what happens? Like say this is fx, this function is fx, and what I'm doing 2fx. So what will be my new curve? Will be 2 times away from here.
Yes, sir.
This point will be the same, so it will be something like this. And similarly, it will go twice half. So something like this, right? It's like that. So this is 2fx. And if I'm writing a function fx to 1 upon 2, then what will happen? It's something like this, half, So for example, if this point is, let's say this is 2, and this is, let's say 4, this is 8, this is 12, and this is 16. So this coordinate is, let's say 4, 2. So what is the coordinate for red one? The
So
coordinate for red is?
okay, so the coordinates for red would be, and it's 2fx, right? So 8 and 4. Sorry, 8 and 2.
4 and 4, no?
Oh, 4 and 4. Oh,
4 and
my
4.
bad. Sorry,
Right.
sorry. 4 and 4. Yeah.
And for this colored one is 4,
The colored one, and this will
1.
be 4 and 1.
4, right? No. Yeah. Similarly, let's say this is a coordinate 12 and -2, let's say. No. So this new coordinate will be 12
12 and
and
minus
-4. Correct.
And similarly, that one will be 12 and -1.
Right. That means like that, Okay, so that was a vertical stretch. Now let's see
So what about, so after this, can we do like odd and even functions as well?
Yeah, we are going to do that. So, odd and even function we'll do modulus function, we'll do reciprocal function, right?
Yes, sir, yes, sir.
Right. So everything we will do. So horizontal stretch mein fx is how to write, you tell me?
Yes, sir. So in horizontal stretch, right? So f, if you wanted f either 1 by ax would mean that the stretch will
Bx.
increase.
Let's write like this.
Bx.
Because we are multiplying with the x. Last time we were multiplying with the f, the entire.
Where,
With the entire
okay, so we can write where when b is less than 1, the horizontal stretch increases, and when b is more than 1, the horizontal stretch decreases.
Okay. So so what is the scale factor now?
So so the scale factor would be 1 by b.
1 upon b. Correct.
Yeah.
No. And because this is reciprocal, that's why it happens opposite.
Yeah.
If b is greater than 1, then points you tell me, come close to y-axis or go away from y-axis.
Okay, so points if it's a horizontal stretch, right? So if
b is greater than 1,
if b is greater than 1, then the horizontal stretch would they would go closer, right?
of course, because it is, let's say b is 2, if b is 2, let's say, then scale factor is 1 upon 2.
Yeah.
That means points will come close to the y-axis, right?
Yeah.
Points come close to the y-axis.
Yeah.
And if b is less than 1, then points, but greater than 0, then points go away from y-axis. And points at the y-axis remain invariant. Y-axis will not change. right? Okay,
Understood.
let's see one example. Let's see this is right curve. So let's say this is curve fx, and for this curve we are doing similarly f2x we are doing, and second we are doing f let's say 1 upon 2x. Okay.
Yes, sir.
So how is going to happen? Let's say I'm just putting some numbers over here. This is 2, and this is 4, and this is 6, for example. So our new curve is going to be how? Let's say for 1, and this
Yeah.
for
So
no.
So 1/2. So for first one, it would so the horizontal stretch would go closer, right?
Yeah.
So six would decrease. So
6 will come to 3,
six
right?
will
Or
come
2
to 3, 4
come
will
to
come to
1.
2, and 2 will come to 1.
Correct. So curve will be something like this, isn't it?
Something like that. Yeah, something like that.
Right. This is 4, and let's say I'm taking this point as -3. So this is 4 -3. Then this new coordinates will be 3 -3, isn't it? No, sorry.
No.
This is a 4, so 2 -3, right? This is going to, isn't it? Because
Yeah, let's
halfway,
say
it is halfway,
yeah.
And like say when it is going to double, I mean, like the second one. So because scale factor in the second one is 2, and the first one scale factor was half. So now the points are going like away, So this is 6, so it will go to 12, and of course, and this vertex like 4 will come to 8, So it's something like this,
Understood.
something like this,
Yeah.
something like this. No, that's it. This is F1, and that one was F. That's how we have,
Got it.
Just let's write once this coordinates. So let's say the vertex will change to earlier it's got 4 -3, right?
So it'll turn into 8. So it'll turn into
8
8 minus 3.
And 6 will change to 12, right?
Yeah.
And yeah, this 2 will change to 4. Basically, this is a little bit wrong because it is not 4, like it should be like this, basically, But it's fine,
Understandable, sir.
Yeah.
Yes, sir.
It should be 4.
And so then with more, then I think the mod functions, right? Where
Yeah. Let's say if you look at the mod function here in the same place. So if I'm making mod x, mod x, and in that case, whenever my curve is like this, so this will change to, because it's a mod for entire function. So the negative part will become positive, and
Yep.
my new function will be like this, will be like this, right?
Yeah.
If we are doing okay, we'll come to mod properly. So this is a stretch, and the third one is what did I write for third?
For third, as in?
I think reflection.
Yeah,
Right?
reflection.
Yeah, let's see like quickly reflection also.
So minus fx.
Correct. There are two basically. Minus fx and
Minus fx and second if f minus x. Yeah.
f minus x. F minus fx is what?
So minus fx would be y being also reflected over the y-axis.
Yeah, minus fx, no, reflection in the
Sorry,
x-axis.
X-axis.
Right. Reflection in x-axis. And this is reflection in y-axis.
Got it.
In y-axis. We also call them vertical reflection. This is vertical reflection. And this is horizontal, right? Let's see it quickly. Let's say if I have this curve, then my reflected curve will be something like this. Something like this. No, that's a vertical reflection. So let's say this point is 3. So this is -3. This point will be same. Let's say this is 1. This is 1. Let's say this is 5. This way.
X parts will be the same, but Y will reflect.
Correct. This is, let's say, 1, 5, 6, 3, minus 2. So this point is going to be 3, comma, right? That's the vertical reflection. And let's quickly see the horizontal reflection. So let's say take the same type of curve. So this is a curve. If I am reflecting in the vertical axis, which is Y, so it is
So
going to be something like
it'll
this,
switch the other side, yeah.
right?
Yeah.
This is a vertex of 3, comma, minus 2. So new vertex will be what? Minus 3, comma, minus 2.
New vertex will be minus 3.
Yeah. And the points at the y-axis will remain in value, right?